Hi guys, I just wanted to give you a very fast and a review about growth modules, emphasizing the most important part about it before you take the exam number 2. The first thing that you need to remember is that what are the difference between these modules? And that's the main key to understand which formula you're going to use in the exam. Remember that the formulas are going to be there. You don't have to memorize them, but you have to know how to identify them. One important thing about the linear growth, and you know what that is going to be linear because it is a repeated amount. You don't see any percentage in any problem with linear growth. And that repeated amount is what we call D. And we are going to see some examples about this. For example, growing the same amount of something weekly, monthly, or annually. So it's a constant repeated amount. That's why it's a linear growth. The exponential growth has a percent-based growth, and that's what we call the rate, which is R. Okay, so you will see in the problem a percentage, like the population rate. And the logistic growth also has R as a percent, but the main difference is the carrying capacity, which is we call K. So if a problem talk about the growing of plants, but doesn't say anything about that the area has a limited capacity of plants, then will be an exponential growth with a percentage as a rate, of course. But if it says that the area where the plants are growing has a capacity of 500 plants, then that will tell you that is a logistic growth. And that is the main differences between these models. Now, let's see, I review some example of each of them. Let's start with the linear growth. Remember that for the linear growth, we have the recursive form and the explicit form. Most of the students ask me how they can identify what is the difference between the recursive form and the explicit form. I always tell them, the recursive form, you're going to find P sub 1 and P sub 2 only. It is a form when you have P sub n minus 1, and it's used mostly to find 1 or 2 years or 1 or 2 months, or just a couple of cycles. Remember that P sub 0 represents the initial quantity. P sub n is the final quantity after n time. And most of the time we use the explicit form when it's more than 2 years. D is the quantity that changes repeatedly, and n is time, that it can be years, weekly, days, whatever the problem is talking about. One thing that we can remember is that the linear growth, the explicit form, is very similar to the slope-intercept form, where m is the slope and b is the y-intercept. In this case, d will represent the slope because the slope is a rate of change, and d is a rate of change because it's an amount that is adding it or subtracting every month, every week, every year, etc. So this idea is important to know because you will see in a problem that I'm going to show you that sometimes we need to find D using the formula to find the slope. And we are going to talk about that very soon. So let's see this problem. Okay, they say that a town has initial population of 70 and grows according to the recursive rule. Remember that the recursive formula is P sub n equal to P sub n minus 1 plus D. That's our recursive form in the linear growth. The first question is, what is the initial population, which is P sub 0? Well, here it says that the initial population is 70. So P sub 0 is 70. And they ask us to find P sub 1. Well, if I'm going to find P sub 1 and I put a 1 here, and here, P sub 1, 1 minus 1 is going to give me P sub 0. So that means that P sub 1 is equal to P sub 0 plus D. But the formula is telling us that P sub 0 is 70 and D is 85. So we add 70 plus 85, and that is going to give you 155. And that's what P sub 1 is going to be. To find P sub 2, then I am going to change here N for 2 because I'm finding P sub 2. Remember, this little guy here represents N. So here will be P sub 2, and this N is P sub 2, is only 2. So 2 minus 1 is going to give me P sub 1. So to find P sub 2, that means that it's P sub 1 plus D. But we find out that P sub 1 is 155 plus 85, that is D. And the final answer here, P sub 2, is going to be 240. So that's the way to find P sub 1 and P sub 2 using the recursive formula. Now, to find the explicit formula, we have to remember that the explicit formula is P sub n equal to P sub 0 plus D times n. When they ask you to find the explicit formula, the only two values that you have to change is P sub 0 and D. So to find the explicit formula, we're going to say that in this case, it's going to be P sub n equal to P sub 0, which is 70, plus D. But even that, the problem doesn't tell you what D is, because it doesn't tell you that certain amount is repeated constantly. The recursive formula gives you D because the recursive formula has D at the end. Therefore, this 85 represents D. So here you're going to put 85N, and that is the explicit formula. That's the only thing that it's asking you to find in this case. However, the next problem is to find P of 100. So that would be P sub 0, which is 70, plus D, which is 85, times N, which is in this case is 100. So that would be 70 plus 8500. So P of 100 is going to be 8,570. And that's the way to use the explicit formula to find P of 100. Let's see other examples. Now, in this case, it's telling you that the population of elk in 2003 were 12,000, and it grew to 15,000 in 2007. And the question is, what would be the elk population in 2014 if it still grows linearly? Notice here, guys, that we do not have D. It doesn't say how many elk grow every year. So we need, the first step that we have to do is to find D. And this is what I told you that we're going to use. If you remember how to find the slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay, so my first point here, I know that in 2003, and X always is going to be the year, I have 12,000 elk. And in 2007, I have 15,000 elk. And these are the points that I'm going to use to find D. So I said 15,000 because this is y sub 2. This is y sub x sub 2, this is y sub 1, this is x sub 1. So y sub 2 is 15,000 minus y sub 1, which is 12,000, and then 2007 minus 2003. And when you solve this, it's going to give you D. It's going to give you 750. What is the meaning of that? That according to this linear model, we have a population, a new population of elks, of 750 elks every year. Now, to do the explicit form here, which is again, is P sub n equal to P sub 0 plus D times n. And I will suggest constantly on the exam to have these formulas in front of you. Again, you will have them in a sheet of paper. So be sure that they give you the exam and they give you the formula sheet. So P sub 0, we know that the initial population was 12,000. And we found out that D is 750. And so the explicit form would be P sub n equal to 12,000 plus 750 n. But the question is, what would be the population of elk in 2014? Well, I need to figure out n. So I'm going to subtract 2014 minus 2003, which was the initial year in this case, which is 11. So n is going to be 11. So what I have to do is, in the explicit form of formula, find P sub 11, which is going to be 12,000 plus 750 times 11. And that gives me 20,250 elk. Most of the time, if you have a decimal, we should round up to the whole elk, because we cannot have 0.4 elk. So be careful with that. So this is the way to find D. Remember, we are going to use the slope formula to find D, and then we can do the explicit form. Now, in this case, it's asking us the population after 10, it says that the initial population is 4 beetles, and the population after 10 weeks is 114. Find the explicit formula. Okay, again, we don't have D here. So if in the 0 week, okay, in week 0, the population was 4, and in the 10 week, the population is 114. So what we have to do is subtract 114 minus 4 divided by 10 minus 0. That will give you 110 divided by 10, and this is 11 beetles per week. That would be our D. So the explicit formula would be P sub n equal to 4 plus 11n. Now notice that I use 0 for my first week. And so remember that, unless it says specifically that the first week is going to be P sub 1, but it doesn't say anything, use 0. Now to figure out when the beetle population would be 235, so we're solving for n. So here P sub n, which is the final amount after n weeks, is 235. And then P sub 0 is 4 plus 11n. So I'm going to subtract 4. And that is going to give me, what is it, 231 equal to 11n. So now I divide both sides by 11. And now n gives me 21 weeks. So when it asks you when, we're talking about time, we have to solve for n. And that's the way to do it. It's an equation, so we use a little bit of algebra. The last example about the linear growth is give you something like this, and it's asking you to tell me or tell us what does the equation is about. Again, remember that the equation is P sub n equal to P sub 0 plus D times n. So the only thing I can talk about is the 70 and the 30. The 70 is P sub 0. So I can say that the initial cost of the membership is going to be $70. And D represents the repeated amount. That means that monthly, you are going to pay $30. So the only thing I can say is that the monthly cost is going to be $30, because again, D is the amount that you will pay every month. And that's what I have to say about the linear growth. Okay, let's go to the exponential growth. Here are the explicit and recursive form. We don't use the recursive form too much in the exponential growth, mostly the explicit form. One thing that we have to remind you that this is called the growth multiplier or common ratio, and the R is the growth rate, and N again is time, and P sub 0 the initial amount. P sub N the amount at the end. So let's say this example. You see that as soon as I see a percentage here, I say, okay, this is not a linear growth problem. And when I read it, it's just talking about, doesn't say anything about a capacity amount. So that is not logistic growth. Okay, so notice that it's asking you what would be the population in 2020. Well, don't get confused because you have two years here. Because it says between 2007 and 2008. You will use 2008 as the year where you have 245,000 people. Okay, so be careful with that. So to find, I know the N is going to be 2020 minus 2008, so it's 12 year. So what we're looking is for P of 12, P sub 0 again. Let me just write here the formula so we know what it is, okay? So P sub 0 is 245,000 plus 1 plus, now be careful when we change percentage into decimal. Remember that we have to move the decimal point 2 times to the left, and every whole number has the decimal point in the back. So this is 1, 2, so I need to add a 0 in the front. Be careful with that. Oh. Elevated to the 12. So in your calculator, you just can put this 245,000 times 1.03 elevated to the 12th power, or you can start with this part here and then multiply by this here, and you should get 349,311.4 people, but you should round it to 311 because we cannot count 0.4 people. Okay, and that's the way to use the explicit formula for the growth model. Okay, here we have to find it. So we have the growth rate and we have P sub 0. Again, this is equal to P sub 0 times 1 plus R elevated to the n power. Okay, so the explicit formula is going to be P sub n equal P sub 0. Here is telling us that it's 9 times 1 plus 0.15 to the n, which is 9 times 1.15 elevated to the n power. And that's what you're going to use to find P sub 11, which is going to be 31.7, which is 32 rabbits. We talk about rabbits here. And that would be your final answer. Again, the important thing for me, I feel that having the formula constantly in front of me helped me to identify what information I have and what I have to find out. Here again, it's just giving you this exponential form and it's asking you what is the meaning of that. And we talk about an annual tuition of a college in 2010. So since this is the formula, I can say that P sub 0 is $4,600. So I can say that the initial tuition is $4,600 in 2010. Now, the 1.072 represents 1 plus R. So if I subtract the 1, I will get R. Okay, so I can say if I change this into percent, which is moving the decimal point 2 times to my right, I can say that the tuition will grow 7.2% or per year. Or, increase, or the tuition will increase 7.2% per year. That's what the rate we said about that problem. Okay, let's see here. Here, they're asking you to find the emission growth by 2050. However, when you look at the problem, it says that grow exponentially, but you don't see any percent. So that means that part 1 is to find R, because I don't have the rate there. Okay, so P sub n in this case is going to be 1182, which is here, and it was in 2000, into year 2000. Then P sub 0 is going to be 962. Now n is 2000 minus 1990, which is 10. So this is going to be 1 plus R, because we don't know what R is, elevated to the 10th power. Okay, using a little bit of algebra here, I'm going to divide, because this is a product here, I'm going to divide both sides by 962, so these two cancel, okay? Now, I have here an exponent 10. The inverse function of an exponent is going to be the radical, the root. So what I have to do is elevate both sides, or find the 10th root of both sides. And I'm not going to solve this yet, guys. Just leave it like that. So when I find the 10th root here on my right side, the 10th root is going to cancel the exponent 10. So now I have the 10th root of 1182 divided by 962 equal to 1 plus R. So the last step that I need to do is to move the 1 to the left side. So R is going to be the 10th root of 1182 divided by 962 minus 1. Now be careful, when you put this in your calculator, be sure this minus 1 is outside the radical. It's not inside the root. And when you do that in your calculator, R is going to be approximately 0.025. Now that I have R, I have P sub 0, and I can look for what are the emissions in 2050, and it's going to be 2050 minus 1990 is 60. I can look for P of 60, which is going to be 962 times 1 plus 0.025 elevated to the 60 power, which is 962 times 1.025 to the 60 power. And I got that in 2050, we have 4,074.2 million metric tons. Don't forget to write the measurement. Metric tons of carbon dioxide. And that's the way to find R using the radical. Now, the next one is a little bit different because on the next one, we are going to use logarithm because in this case, we know n, which was 10. But in the next case, we need to find n because it's asking us when. So P sub n here is 400,000. You can leave it like a 400 only. You don't have to write the whole thing because already this amount here is in thousand. And so when I translate this into the equation, it's going to be 400 equal to 245 times 1.03 elevated to the n power. Again, the first thing we're going to do is divide both sides by 245. Do not solve that yet. Let's do all the algebra first, and then you solve it because it's easier. And this is what I have left. Okay. I don't have time to explain all the logarithm properties, but we have a property that allows us to move this exponent here to the front so we can solve better the equation. So to do that, what we're going to do is to write log of 400 over 245 equal to n times log of 1.03. Ta-da! Now we have the exponent down so we can solve this. And now what we're going to do is to divide both sides by log of 1.03 because this is a multiplication here, so we can do it, and this one cancels this one. So n is log of 400 divided by 245. Be sure to use parentheses in your calculator. Divided by log of 1.03, and that is going to give me approximately 16.6 years. So when you have the exponent and you're just finding r, we use radicals. When you're looking for n, which is time, you have to use logs. Okay, guys? Okay, and the last part is about logistic growth. Again, remember that you're going to have a carrying capacity that we're going to call K. That's why you're going to identify that it's a logistic growth. And this is the formula. The formula will be there. Now, when you use the formula, guys, and I'm going to show you with one problem, be sure that you solve this part first. Okay, do not add these two. No, that's a no-no. Okay, you just solve this part first, this part here first, round it to the whole number, and then you add it. Okay, let's do this. So it's asking you to predict the population in the next 3 years, but I'm going to do only 2. Okay, I'm going to do only 2. Okay, if you want to practice with 3, have fun. Okay, to find P sub 1, P sub 0, again, let me write here the formula so you can follow me. -1 plus r times 1 minus P sub n minus 1 divided by k times P sub n minus 1. Okay, notice that 20 is the P sub 0. R is the rate, which is 0.7. 1 minus 20 divided, and here says they support a maximum population of 300 plants. So that is your carrying capacity. That would be K times 20. When I solve this part, notice that I did not add 20 plus 0.7. When I saw that part, it gave me 13. So I have 33 plants. It was 12 point something. I believe. So now to get p sub 2, now I'm going to have p sub 1, which is 33, plus 0.7 times 1 minus 33 divided by 300 times 33. So that gives me 33 plus 21, and I got, what is it, 54 plants. So again, be sure to work with this part first, round it to the whole number, and then you add it to the other part. And the last slide is about identify the graph. You know that this is exponential because it's going down very rapidly, or it can look like this and keep growing. That would be exponential. Linear, it would be a line that could be that way, like that, or it could be this way also. And logistic, notice that logistic grow very fast and then stay up and down steady, or it could look like this too. Now notice that the difference between these two is that the exponential will keep growing. We keep growing. But the logistic will in one point kind of stay steady or goes up, down, up, down, up, down. Okay, guys, I hope that this helps a little. And email me if you have any questions. Don't forget that I send you the review also with the answers. And good luck with everything.